Hello, I'm Nick Hodges, the Delphi Product Manager, and welcome to Turbo Delphi Demos, another edition. We've been slowly working our way through some object-oriented programming techniques, and today we are going to talk about the third pillar of object-oriented programming, which is polymorphism. Now, this is the same project that we've been working on previously, where we looked at encapsulation, and we saw how a class can be encapsulated by gathering up all of the data and the methods or functionality on that data into a single entity called a class. That was encapsulation. And then we saw inheritance, where we can descend from the class of type T person and create a new descendant class, in this case a T employee, that inherits all of the functionality of T person and then can add indeed its own functionality later on. And today we're going to talk real quickly about polymorphism. Now, polymorphism is probably the most difficult of the three concepts to sort of understand, because it actually is kind of the most complex of the three. Generally, polymorphism is the ability for something to, as in the Greek form of the word, appear in many forms. Polymorphism refers to the ability of an object to process and perform differently depending upon the data type or class of the original base type or the declared type. A little more specifically, it's the ability to redefine the methods of a derived class and have the proper methods called even when the type of the object is a parent type. And that doesn't necessarily sound all that easy to understand, or maybe you don't have any idea what the heck I'm talking about, but we're going to demonstrate it here for you in a minute, and we can see that we'll see how it works. So in order to see polymorphism in action, you need to have a couple things already set up, and we have them, fortunately. One is you need to have a base class with a virtual method or methods, and then you have to have a descendant class with some of those one or more of those virtual methods overridden. Okay? Now, in this case, we have the function class full name, which, as we scroll down here, you can see creates the name of the employee, here it is, or person, by just adding a first name with a space and the last name. Now, in T employee, the descendant class, we overrode the functionality of full name. You'll notice that full name is declared as override of this virtual method, and we change and alter the behavior. In this case, we wanted to be very polite to our employees, and we wanted to call them associates. When we ask for their full name, we say Associate Nick Hodges or Associate Fred Flintstone. And so that functionality was overridden. Now, with polymorphism, what that means is that we can declare a variable at the very base functionality. We can declare a variable called sum. Well, actually, here's what I'm going to do. No, that's fine. Var sum person of type T person, right? We can do this. Now, we can come down to the main portion of our code, and I am going to delete all of this to clear out the functionality here so we can see very clearly. Now we have a variable called, actually, what am I going to do? I'm going to come down and I'm going to grab this and put it here so we can see everything on one screen. And I'm going to remove that. Okay, so now we can come down and we can say that some person, which is declared of type T person, we can say some person gets T person dot create. We can do something to that person. We'll remember to free it up first in the try finally block, which we've looked at before. Then we could say some person dot first name gets Barney. Some person dot last name gets Rubble, semicolon, and then we can right line out some person full name, we can write that out. And if we save the application and run it, we will get Barney Rubble comes out into the console window. Okay, that's all boring. We've done that before. But here's the real interesting part now, whereas we start to get into the very, very basics of polymorphism, looking at how polymorphism works. You notice here that we declared some person as of type T person. And we declared, and then we created an instance of T person here, and we assigned it to the variable some person. Well, here's the interesting part. You'll notice again that since employees descend from T persons, all T employees are also T persons. So now we can come down here, and even though some person is still declared as type T person, we can change this declaration to be T employee. So we can assign an instance of T employee to some person, even though some person is T person, not T employee. Okay? Because, and that's the very, very base functionality of as simple an example of polymorphism as you can get. All employees are T persons, therefore you can create an instance of T employee and assign it to a variable of type T person. Okay, so now we're about to see polymorphism in action. What's going to happen when we run this is polymorphism is going to take over when we call this virtual method down here full name. Now, some person is declared as type T person, but it's created as type T employee. So polymorphism dictates that even though this is a type T, even though the variable is of type T person, the base class, the parent class, when we call full name, we call the proper full name based upon the type that was created. So when T person, when some person dot full name is called, the version of full name, remember full name was overridden here, the version of full name that gets called will be the proper one for the type of the class, that is T employee. So you'll notice that if we run this, we don't get Barney Rubble, we get associate Barney Rubble. And that is polymorphism in action. Now, one other thing to note is that even though we get the right version of full name via polymorphism when we call full name on some person is still a base class of T person. So if I come down here and try and add, for instance, employee ID gets 33 or whatever, that will be an error because some person is declared as a variable employee T person, and T person itself doesn't have the employee ID. As you can see, the employee ID field, which was added as part of T employee. So this thing remains a T person, but it calls the proper full name function via polymorphism. And that is, in fact, polymorphism in action in a very simple example. So that wraps it up for another edition of Turbo Delphi Demos. Thanks for your attention, and we'll see you next time around.